Okay, welcome parents and boys and girls. Today we're going to be doing our third division strategies using the area model. We already know, boys and girls, that we can draw an area model for multiplication. We know that if I take the dimension of 3 and 5 and multiply them together, I'm going to have 15 small boxes inside my array. When we look at division, division is just the opposite. We know what the first dimension is, the width. What we don't know is the other dimension. But we already know how many blocks will be inside our array, 9,448. So what we're going to do is we're going to switch or rotate our area model. And we're going to put the divisor on top. And we know that this dimension times this length is going to equal 9,448. So that's how you set it up. And we're going to find out what this length is. So the first thing that we're going to do is we're going to think about 7 times what? Of course, we're going to look at our number. We've got 9,000. So we've got 9 thousands, 4 400s, 4 tens, and 8 ones. So the first thing that I ask the boys and girls to think of is if you've got 9 thousands, what could we do? What could we multiply 7 times? Okay, well we know that we could do 1,000 each. And of course they may want to revert back to looking at their web model. If they were doing their web, they'd have 7 spokes around it, and they would be able to put 1,000 in each. 1,000 times 7 is 7,000. And I'm going to draw a line like so. And then, of course, I get to subtract that from what I already have, because I've already divided it. And that gives me 2,448. So 7 times 1,000 is 7,000. Now, I want to figure out 7 times what gets me close to 2,000. Well, I've been teaching the boys and girls to kind of look at the first 2 numbers and think of it as a basic division fact or multiplication fact. 7 times what is going to get me close to 24? Well, 7 times 3 is 21. Well, I'm not going to do 7 times 3. That's not going to be enough. I don't want to take 21 from here. And 7 times 30 would give me 210. That's not very much. But if I add another 0, that gives me 2,100, which is a great number for getting this down quickly. I don't want to do it in too many steps if I don't have to. So now I'm already in 2 steps, I'm down to 348. So again, I told the boys and girls, let's look at the first 2 digits. It's 34. How many times can 7 go into 34? Well, I know 7 times 5 is 35. That's too much. So I'm going to do 7 times 4. 7 times 4, no, that's 28. That's not enough. 7 times 40 would give me 280. That's perfect. And I'm going to end up with 68. So I'm getting to a nice number that I can handle. So 7 goes into 68. Well, I know 7 times 10 is 70. So I'm not going to use 10, I'm going to use 9. And 9 times 7 is 63. And I'm going to subtract, and now I have 5. Now, can I get 7 times a number and get 5? I cannot. So that's actually going to be my remainder, which is 5. And I can close up my array. So now you can say I have 7,000, 2,100, 280, and 63, which is actually going to equal 9,443. Okay? And then if I add in my 5, I'll get 9,448. So what is my answer? What is my quotient? This is what I didn't know, which is n. N is this dimension. We knew what the 7 was. We just didn't know what this is. Well, I know from here to here is 1,000. From here to here is 300, 40, and 9. So I'm just going to add these up. And I end up with 1,349 with a remainder of 5.